Today our lesson is going to be on slope. This follows straight from constant rate of change that we've been talking about. First thing you need is a definition of slope. Slope is used to describe the steepness of a straight line. Slope is calculated as a ratio. When we calculated constant rate of change, we were also calculating a ratio or a fraction. So here you see we've got the definition of slope. And then we see that slope equals rise over run. That should be a review from 7th grade. Rise is the vertical change. That means how it's changing up or down. If it goes up, it's positive. If it goes down, it's negative. And then the run is the horizontal change. That should make sense. When you're running, you're going from left to right. So left is negative, right is positive. Slope is equal to rate of change. So we've been finding the rate of change the past few days. And slope is basically the exact same thing. It's just another way of thinking about it. So slope is also equal to the change in range over the change in domain. And if you see right here, it's kind of difficult to see, but we can actually let change in be represented by a triangle. So a triangle means change in. It's kind of just a shorthand way of writing that so you don't have to actually write out the words change in every single time. So same thing as change in range over change in domain is delta y over delta x, or change in y over change in x, which is what we've been using for the past few days. So now let's look at an example. This is on page 344 in your textbook. The exercise example, which is that treadmill, the directions say find the slope of the treadmill. We've got our formula, slope equals rise over run. That was from the definition of slope that we saw on the last slide. The rise of this treadmill is going up or down, so that would be 10 inches. The run is going left to right, so that would be the 48 inches. So they did 10 inches over 48 inches. And you can simplify by dividing by 2, and they got 5 over 24. With slope, we're still going to simplify. We are not going to change improper fractions to mixed numbers. Okay, so if it's improper, leave it improper just like we have been. Example A, a hiking trail rises 6 feet for every horizontal change of 100 feet. Well, we have to know what horizontal means. Horizontal means left to right, so that would be 100. And it says it rises 6 feet. So that means it goes up 6 feet. So we've got this triangle. We want to know what is the slope of this hiking trail. So looking at this, we know that slope equals rise over run. The rise of this would be 6, and the run would be 100. Now, you can ask yourself, how would this be negative? The only way this would be negative if it said a hiking trail falls or descends 6 feet. If it was going down for every horizontal change of 100 feet, then we would have had to put a -6 right there, and that would have made our answer negative. So make sure that your answer makes sense in the context of the question. We can actually simplify this. We can divide by 2. When we divide by 2, we get 3 over 50. So that would be our answer. The slope is 3 over 50, or 3/50. Other forms of slope. Slope is also equal to change in y over change in x. That's what we just talked about, which is the same as rate of change. When analyzing a graph, look for the slope triangle. Now that's only specific to a graph. Okay, there's different ways of calculating slope depending on the information that you're given. If you're given a graph, we can just use a slope triangle, and I will show you how to do that on this slide. So we've got this slope triangle here, and we want to know what is the slope of this line. Well, I can tell you, since it is going up from left to right, that it's going to be positive. Okay, so we're going to do the rise first because we know that slope equals rise over run. So if I start here, I'm rising 1, 2, 3. So I'm rising 3. Running, I'm moving right. So 1, 2, 3, 4. I'm moving right 4, so that's positive. So my slope is positive 3 over positive 4, and that cannot be simplified. So 3/4 is my answer. Okay, on the other hand, this other graph over here I see is falling from left to right. It's going down. That tells me the overall slope should be negative. So if I'm looking at this, we want to calculate the rise first. So calculating the rise, I'm going to start here on my line. Always start on your line and move to the corner of your triangle, your slope triangle. So I'm starting on the line and I'm going to go 1, 2, 3, 4, 5, 6. Down 6 tells me -6. And then from there I move 1, 2 to the right. So that's a +2. So since I moved down, it was negative. And since I moved right from there, it was a +2. So my slope, rise over run, would be -6 over +2. That can simplify, dividing by 2. When I divide by 2, I get -3 over 1, which is the same as just -3. Okay, so slope triangle we can use when we're dealing with a graph. However, in D, they give me a table. I'm going to solve a table the exact same way we did the other day for constant rate of change. So if I'm looking at this, my x values, I've got to see what's happening each time. It's easiest right here between 2 and 6. I can see that they're adding 4. However, we are continuously adding 4. For my y's, it's easiest to see from 0 to 1 that they're adding 1. But they are adding 1 every time. So my formula, delta y, change in y, over delta x, change in x, gives me a +1 over a +4. My y's are changing +1, my x's are changing +4, so the slope is 1/4. Looking at E, our x values, we can see that they are adding 4 every time. Our y values, we can see they are subtracting 1 every time. So delta y over delta x equals -1 over 4. Very, very important that you get the negatives and positives correct. So that one, the slope was -1/4. Here's our slope formula if we're given 2 points. So we've looked at a slope triangle if we're given a graph. We do a table the same way we did constant rate of change. And now we're going to look at what if they give us 2 points. So right here, make sure that you put this in your notes. M equals y2 minus y1 over x2 minus x1. The variable m is used to represent slope. Point A, it really doesn't matter which point you choose. One of your points you're going to label as x1, y1. The other point you're going to label as x2, y2. Very important that the 1s are in the same ordered pair and that the sub 2s are in the same ordered pair. But it doesn't matter which ordered pair is which. You'll see that when we work out a problem here in just a second. Alright, so looking at this, why the letter M for slope? It's actually not known why the letter M was chosen for slope. The choice may have been arbitrary. John Conway has suggested M could stand for modulus of slope. One high school algebra textbook says the reason for M is unknown, but remarks that it is interesting that the French word for to climb is monter. However, there is no evidence to make any such connection. Descartes, who was French, did not use M. In Mathematical Circles Revisited, mathematician's historian Howard W. Eves suggests it just happened. So we really don't know why they chose M, but they did, so we're going to use M to represent slope. Okay, so right here, we've got the 2 points, 2, 2, and 5, 3. So I'm going to actually label these. I'm going to label 2, 2 as x1 and y1, and 5, 3 as x2, y2. My formula is m equals y2 minus y1 over x2 minus x1. Put this in your brain. It is so important that you know that formula. Alright, so substituting, y2 is a 3, right here. 3 minus y1, 2, over x2 is 5, minus x1 is 2. Very important that you subtract there. If it's negative, make sure you use parentheses. 3 minus 2 is 1. 5 minus 2 is 3. So our slope in this case is 1/3. If you can simplify, remember to simplify, but leave it as a fraction. Do not change it to a mixed number. Let's look at, we're going to skip actually to example H. So looking at this one, I've got -7, -4, and I'm going to label that as x1, y1. And then I've got the point K, -3, -2. Okay, that'll be x2, y2. Alright, filling this in, I have m equals y2 minus y1 over x2 minus x1. Substituting, y2 is -2 minus y1 is -4. This is what I was talking about with parentheses. x2 is -3 minus x1 is -7. Okay, -2 minus -4 is a +2. -3 minus -7 is a +4. So that simplifies to 1/2. Now, right here we can actually graph these and check the slope triangle. We can use the slope triangle to check. -7, -4 would be right here. Okay, and then -3, -2 would be right here. And then I just need to draw a line. Alright, so if I want to draw a slope triangle, I just connect those points. So I could draw my triangle like this. Alright, we want to do the rise first. So I would have to go down 2, that's -2, and left 4, that's a -4. So my slope would be -2 over -4, which is the same thing as +1/2. So you can see we do get the same answer no matter if we graph it and use the slope triangle or if we actually use the formula. Alright, now I want you to open your textbook to page 347. Complete problems 1 through 6. Make sure you read the directions. When you finish these 6 problems, come show them to me to get your homework assignment, and I will check them and give you feedback.